Hello grade 12s, welcome to my channel, and let us give you some more practice for your NBTs. And you will find a document, a PDF link to download this document in the description of this video down below. See where it's written more, just click there, you'll find the link to that PDF. As well as the answers provided here, you'll also be able to download that PDF as well. So let us go for it and see. So we've got a question 39 here. So remember, the order in which these questions are numbered in this video is not important because I took these from different question banks, so that's just the idea. But essentially this will assist a student to practice their maths, to better understand certain nuances. At the same time, it will also make you more ready for your NBTs. Now we are given the graph of y equals a into 3 to the exponent x plus b, shown below. So when we look at this expression, this is an exponential graph. This is an exponential function. Sometimes I write that way in short. So with this exponential function, we know that there is a property for an exponential function. It has what we call a horizontal asymptote. Question is, where should you draw it? Must you draw it there? The answer is no, because an asymptote is a number that, it's a line, it's a horizontal line that lies very close to the graph, but it never intersects the graph. So this is the best position to indicate this horizontal line. This is our asymptote, and in our exponential equation, it is represented by the constant, which would be letter b here. So it means this is where it cuts the y-axis. Okay, and then we've got a coefficient of the power, which is the letter a. So what is the importance of the letter a? It gives us two things: whether the graph appears above or below the horizontal asymptote, or when this sign is combined together with the characteristic of our base of the power, then it can also tell us whether this function is increasing or decreasing. All right, so if we look at this graph here, we see there's our horizontal asymptote. It essentially appears below the horizontal asymptote. So this tells us that our a is less than 0. Sorry, let me just sort this out. This is the origin. So this means a is less than 0. So there's a few parameters that we can look at. We know that b here, not capital letter B, but small letter b, is the horizontal asymptote. I will write it like that. And if this is the horizontal asymptote, we know that b also represents a vertical shift. Okay, in a way. Okay, so that is key. So we know this is the horizontal asymptote, which is the property of an exponential function, but it also represents a vertical shift. That's something we need to appreciate. Now, let's have a look. We have established that our a is less than 0. How did we know? We knew because the graph is below the horizontal asymptote. Okay, so that's why we know that a is less than 0. Okay, great. But we can also appreciate that our base of the power is greater than 1. Okay, remember the base must always be greater than 1 or less than 1 at the same time greater than 0, but it cannot be equal to 1. Why? Because for that exponential expression to be a function, we need to see certain changes taking place as we vary some of the variables. Now, when the base is 1, nothing changes. Okay, great. So this is evident in the given expression. But we know something, that these two, the A nature, or the nature of A, be it positive or negative, together with the quality of the base, it will tell us whether the graph is increasing or decreasing. But now this combination, this A and B, which is the base this time. Remember, B was used for the asymptote, unfortunately, but we normally use B to denote the base of the of the exponential expression. So these two together, they give us the fact that this graph is a decreasing. It's a decreasing, let me see, how do I write a decreasing function. Okay, basically it's a decreasing function that appears below the horizontal asymptote, that appears below the horizontal asymptote. Okay, so we are happy now because we understand a lot of these things nicely. So what is the question? Choose the correct descriptions of A and B. We can see A is less than 0, B is greater than 0. So we want that combination. It comes out for option D. All right, so we can make a conclusion that therefore the answer to this question here is option D. I don't know how to write a D properly, you know. Hey, my D is just not a D. Okay, masiyeke kanjani. Alright guys, so it helps a lot to know a few things so that one can essentially, master these. So we see this is a decreasing function. And remember, for one to read whether a function is decreasing or increasing, one must read from left to right. Okay, please don't read any other way. Read from left to right. Then this quality of a function can be clearly depicted. Otherwise, if one does something else, then we start to experience a few difficulties in deciding what is going on. Okay, now let's go on to 43. 43, we are given the graph of y equals ax squared plus bx plus c is shown below. Okay, this is the standard quadratic function. Okay, so this is the standard quadratic function, but perhaps let's write what we are given. Plus c. This is basically the standard quadratic function. So what can we say about this function? Well, if it is given in the standard form, we can't say a lot because this is a hypothetical equation essentially. Now, we need to study what is going on this graph. As we can see, we've got the origin here, right? Then we will appreciate that our graph is concave up, right? So when this graph is concave up, it means the coefficient of the highest degree power in this expression is of the order of 2. Okay, right. What did I say? The coefficient of the highest degree power in this expression is positive. That's what I meant. Now I started talking about the x squared, not necessarily. Remember, for the quadratic, it means the highest degree power here is going to be in the order of 2, and we see that from the exponent. But now we are only focusing on the coefficient of that highest degree order power. The idea is that when it is concave up, we can appreciate that this is essentially suggesting a is greater than 0. So in this, we can appreciate that our a is greater than 0. Why? Because the graph is concave up. Okay, so when it is concave up, we often refer to this as a smiling parabola. Okay, so one would often hear such inferences that this is a smiling parabola. It's essentially concave up. Okay, we move on. Say, what about the coefficient of x, which is b there? B often is associated with the axis of symmetry. All right, so this thing is not so nice, eh? Okay, there we are. So often the axis of symmetry is essentially right at the x coordinate of the turning point. And we can see this is on the negative x-axis. So what does that mean? We understand that essentially in this function, the x coordinate at the turning point gives us the axis of symmetry, but it is such that from the standard equation, it is defined like that. Okay? But now we look at this graph, we can see that that x coordinate is negative. So this implies that minus b over 2a is less than 0. 0 over 1. Remember, we never divide by 0. Now here's the thing. We are allowed to perform the gymnastics of cross multiplications, but with inequalities, it becomes a little bit tricky. This is where you don't just do as you please. You must be forever careful. But here's the advantage to this. We need to know the quality of that variable. What is the quality of this variable? It's positive. So this means this value in the denominator here is positive. Now once we know the sign of that variable before we cross multiply, then we can do this safely because we will be able to know whether this inequality changes or not. So when we cross multiply here, we'll appreciate that 1 times minus b is minus b. Now the sign doesn't change because we are multiplying across with positive numbers. So this is going to be like that. Therefore, when we multiply by a negative, the sign changes now. And we can see b is greater than 0. Okay, that is important. Okay, this is what gives us the axis of symmetry. All right. Great, so we can appreciate that. Obviously, even from inspection, you can just look at it and say, look, if this is to be negative, knowing that there's an innate negative in the expression that helps us determine the x-coordinate at the turning point, from the standard equation. Therefore, for this to be entirely negative when a is greater than 0, it means b must also be greater than 0. So you can see this by inspection, or you can perform a little bit of a calculation where you need to be careful of the signs of variables before you multiply across with certain numbers that carry variables. All right. Now let's answer the questions. At least C, well, we can appreciate that C here is definitely going to be positive. Why? Because we will see that this graph will certainly cut the y-axis on the positive side, right? So that's pretty obvious. So that's the story. So let's answer. We are to pick the correct statement or the correct option here. We appreciated a is greater than 0, yes. B greater than 0, yes. But now this introduces the discriminant. It says the discriminant is less than 0. Is that true? Well, that's not the case, because the discriminant is speaking a language on the nature of roots. Okay? What are roots? These are x-intercepts. Okay. So, do we see any x-intercepts here? Yes, we do. There's one there and there's one there. So that means when we see them, it means they exist. And if they exist, that means our roots are real. Okay? When we say real, we mean they exist, or at least an expression. If it was to be drawn on the Cartesian plane graphically, we would see that graph intersecting the x-axis. But look at those roots. They are unequal. So they are real and unequal. So how should the discriminant therefore be? This implies that our discriminant must be greater than 0. So that statement is incorrect. So let's look at C here. It says a greater than 0, b greater than 0, and the discriminant is greater than 0. This is definitely correct. So it means C is the best option that speaks sense about the given sketch. So it's not gossiping here. So we can add an extra little bit here because we can see it was also looked at. So we will see that the discriminant delta is greater than 0 here. How do we know? Because the roots are real. The reason we know they are real is because they exist and unequal. And we know for unequal roots, it means the discriminant must be greater than 0. Well, we cannot speak about the rationality of these roots because we don't know. They could be irrational, they could be rational. But for us to know that, we would have to see exactly what these values of a, b, and c are, so that we can determine whether our discriminant is a perfect square or not. Because if it is a perfect square, then we can say they are rational. But if it is not a perfect square, we say the roots are irrational. So this is important, guys. So we can see that this essentially concluded that our answer in the question is option C. Okay, so this is very important to really ensure it is in order. Okay, let's move on to the next question. So we've got question 44. Question 44, we are given the graph of 3y minus 2x plus 4 equal to 0. So this is a linear equation, so this is a straight line equation. Now this is reflected in the x-axis and shifted 3 units to the left. Okay, so two transformations have taken place. It's a reflection about the x-axis, which is what we call a vertical reflection. And for a vertical reflection, what actions must we take? We know that y is multiplied by minus 1. So all the y values are essentially multiplied by minus 1. Then when we shift or translate to the left, what do? It means from the x values, we add the number of units by which we are shifting the graph. So this means where we see x, we will substitute x with x plus 3. Great. It says now the equation of the resulting graph is, so we've got to work this out nicely. So we are given 3y minus 2x plus 4 equal to 0. Now for a reflection, so for a reflection about the x-axis and shift to the left by 3 units, it means here on the graph we're going to have 3 into y times minus 1 minus 2. Instead of x, we write here x plus 3, and then plus 4 equal to 0. This implies we've got 3. Remember, this is going to amount to minus 3y minus 2x minus 6 plus 4 equal to 0. This implies we will have here minus 3y minus 2x minus 2 equal to 0. Now let's see, do we have that? Well, this looks like it. Minus 3y minus 2x plus 1. Now there's a 1, so that becomes wrong. That is totally wrong. This is totally wrong. Now we've got all the coefficients 3, 2 and 2, but now the signs are all positive. So what happened here? So this simply means we transposed this left hand side. So we transposed the left hand side to this side. So what action have we done here? A transposition. We transposed the left hand side to the right hand side, and then rearranged, and then rearranged. How do you write arrange? Okay, so that's what we did. So we've done two actions, transposition, and then we rearranged. So if you look in my videos, most of the time I do this consistently, and this is what could give you a surprise in this kind of an exam if you are not familiar with it. So what is important, guys, is that when you learn, don't worry about being crazy or whatsoever. Learn every skill there is, then apply what you choose, but don't choose something and neglect others. And yet this could easily be specifically asked for, because in the end you will lose your head thinking that. And let me tell you, in a nutshell, you see, transposing and essentially rearranging does not change this action does not change the characteristic, the characteristics, okay, it doesn't change the characteristics of any given function. So this is very important to note, guys. Performing a transposition and rearranging does not change the characteristics of the function. So meaning what this function would be when we did not transpose and rearrange remains the same even after we have done that. So as a result, we end up with positive 3y plus 2x plus 2 is equal to 0. So that means the answer here is going to be option D. All right, so that is pretty interesting, is it not? So sometimes you guys think I'm crazy for doing this, but I know why I'm doing this. Okay, it's a coincidence, to be honest, but the reality is I have learned in maths that for you to not be fooled by any problems that are presented to you, you need to know all the tricks, the techniques. Obviously, you will employ the ones you're comfortable with, the ones that you can perform, effortlessly. But at times you may have to employ even those techniques or methods that are a bit uncomfortable for you. So it is important to know them and know them well. All right. Okay, so to drive this home, let me just give you some weird example of what this is all about. Now, those of you who do biology, you nowadays call it life sciences, but this is biology. Or even the ones who are going to do medicine, you will learn about human anatomy and you will see what the human heart looks like and all that. Now, the normal situation, we know blood comes from the head and neck through the superior vena cava and the upper limb as well, right? Enters into the right atrium, and from the lower parts of the body, it enters the heart via the inferior vena cava. It enters into the right atrium. Then blood goes through the right interventricular valve. That interventricular valve is the tricuspid valve, to be specific, but it's not about the name right now. Blood enters into the right ventricle. Now, blood from the right ventricle leaves via the pulmonary artery, and this one goes to the lungs so that this blood can be oxygenated, right? Then that blood comes back via the so-called pulmonary veins. Now, this is oxygenated blood from the lung, enters into the left atrium and through the bicuspid valve into the left ventricle. Then blood leaves through the aorta, and the aorta is connected to the rest of the body yet again. But now here's what is important. We need to know that the pulmonary artery, by definition, is the artery between the heart and the lungs. Okay, that's it. And the aorta is the artery between the heart and the rest of the body. Okay, that is the characteristics of these two. Now, there are some babies who are born due to some congenital malformations. Find that the main vessels or the great vessels are transposed. That means what was supposed to come from the left ventricle is now coming from the right ventricle and vice versa. So that's the transposition of the great vessels. But now, how do we know this is still the aorta then? It's because it's connected to the rest of the body. It's not an artery between the heart and the lung. And if you look at the pulmonary artery here, even though it carries the oxygenated blood at this point, but because it is the artery between the heart and the lung, it is essentially the pulmonary artery. And you will see that even the shapes are somewhat maintained. So I'm just trying to give you the impression that, look, when we transpose things, we don't change their character per se, but they look slightly different. It's like you and I when we buy some fancy clothes or some weird clothes. When we are wearing those, we look slightly different. But guess what? Who's the person wearing the things? It's still the same person we know. So that's the essence of what we say when we say we transposed. So can you see these terminologies actually transcend subjects in a way? All right, guys, that was just to give you a little bit more. Obviously, that example is the weirdest you can come across. Anyway, let's go 46. 46, we are given, or it's a question, on which values or value of x will this function achieve its maximum value, where p is less than 0. Okay, so we can see here that technically this is a quadratic equation. Why? Because the power with the highest degree is in the order of 2. So that becomes a quadratic. Now, with a quadratic, we need to pay attention to the coefficient of this high degree power. Now, that coefficient, because p is less than 0, it means that coefficient entirely represents a is less than 0. And when that is the case, we know that the parabola is essentially concave down. Now, when our parabola is concave down, we know at the turning point will literally carry the maximum y value. Okay, that's why we say maximum. So this is a question about the turning point. Okay, let's write this expression given to us. F of x equals 4px squared minus 6px minus 6x plus 3. So this is a quadratic, but it's not in standard form. So we always write our quadratic in standard form. So this is going to be 4px squared. We factor out a negative, we remain with 6p plus 6, and we factor out the x, then plus 3. Why are we doing all of this? It's because we want to single out that as the a value in the standard format, and we also want to single out this complex coefficient here as the b value, which is the coefficient of x. And lastly, we also want this constant to be clearly out so that we can appreciate that this becomes the c value in the standard format, where f of x is equal to ax squared plus bx plus c. All right, so basically, what is the key function here? You write in standard form. Is it standard form or format? In standard format, whatever. So that is the key action, because we need to get it into standard format. Why? Because look, we are looking for the x value for which this graph reaches the maximum. And that x value is basically the axis of symmetry or the x coordinate at the turning point. So let's see x at the turning point, because that's the one that gives us the maximum value. It's going to be minus b over 2a. Okay, let's go on nicely. This is minus into. Now with complex coefficients, one needs to be very smart about the actions to be taken. Be comfortable using square brackets when necessary. So this is going to be 2 into 4p. Distribute that negative, we literally have 6p plus 6 over 8p. Now, question is, do we have that here? Well, in those options, not. But we can see the probable candidates are those two, because these ones are already suggesting we are looking for the roots. Okay. So now how do we make it look like these ones? Well, we factor out the 6. We get p plus 1 divided by 8p. Now there's a common factor between 6 and 8. 2 goes 3 times, goes 4 times. All right, great. So we then have 3 into p plus 1 over 4p. Okay, it looks like b here, but now we have to redistribute that 3. It's 3p plus 3 over 4p. Okay, so that is essentially easy. That's essentially easy. So essentially we can make sure that we pick up an answer now in this, where it is actually option B. So B is the best answer. Okay, a bit of a flip-flop here, but in maths it is quite common. So what was key here was to appreciate that the x value that gives us a maximum value is the x coordinate at the turning point. And also it was key to notice the highest degree power is in the order of 2 here. Then it means this is a quadratic, and therefore there will only be one value for that. So it can't be values, but just a value. Obviously they're just throwing you a bit of a curveball there so that you can catch fire and burn, okay? I hope you don't burn. All right, folks. So now what was also the defining moment here? The defining moment was to write this in standard format, because without doing so, it would have been a bit silly. It would have been a little bit silly as to what must you do going forward. So I'm just giving you all the skills and the tricks, guys, so that you know what to do when that becomes necessary. Okay, let's look at the next one, 53. 53 says the graph of a polynomial. Now a polynomial is any algebraic expression that contains more than 2 terms. Because when it has 2 terms, we call it a binomial. When it has 1 term, we call it a monomial. All right, but the moment the number of terms exceeds 2, then we can call it safely a polynomial. And the commonest polynomial for your level of study is a trinomial. Okay, right, and usually that trinomial has the highest power in the order of 2. It's quadratic. But remember, all other polynomials, even binomials for that matter, they may have the highest power being more than 2. But it's just the common stuff that we are talking about. It is not so common to find anything that is a trinomial which is not quadratic, okay? But be careful. It's not a must, okay? The polynomial status is only attached to the number of terms contained. It has nothing to do with the type of an expression that is. It has to do with its nature. That's it, okay? Now, we have a polynomial f, and is shown with the turning points, Can you see it doesn't have a turning point? It has got turning points at x is 1 and x is 2. So which polynomial has 2 turning points? It's a cubic. So this is literally suggesting this is a cubic function, okay? It can be any other function though, be careful. But that much we can appreciate at this point. It says now which statement about the first derivative function. Can you see? Now the first derivative function is basically the gradient function. Okay. And literally we are talking about gradients, therefore. All right. Nice and easy. So we can see that here our polynomial is cubic. All right. Why do we know? First of all, it has got 2 turning points. Okay. But it's not always the case, but it is for now, and we can appreciate that. And secondly, the shape of the graph gives it away. Shape of graph is characteristic. Okay. I think balingconywana is characteristic. Okay, so that's why we know this is a cubic function. Okay, let's leave all these stories and not go around in circles. Be careful. I'm going to put some exclamations here that do not for a second attach too much into this. It's something to know, but with a little bit of caution. Now, we are told here that f prime of 0 is equal to 0. Is that so? Well, let's look. Remember, the first derivative function gives us gradients in this graph. So let's see gradients in this segment of the graph. If we draw a local tangent there, at that point, what do we see? That graph is literally positively sloped. So that's a positive gradient. Now at the turning point, when x is 1, what do we see? Well, we will see that the gradient is effectively 0 because it's a perfectly horizontal line. Now let's see on this segment, okay, let's put it there at the origin for convenience, since this question is already speaking about that. What is the quality of this gradient? It's negative, and it continues as such until x is 2, where a local tangent is literally a horizontal line again. So that's a value of 0. And then on the other side, you see that the gradients become positive again. So it says now the first derivative when x is 0 is equal to 0. That's not true. It's actually negative rather than 0. So that's not true. F prime of 2 is less than 0. F prime of 2 is actually equal to 0, so that's not true. F prime of minus 1, can you see, is 0, is greater than f prime of minus 2. Now when x is minus 2, the gradient is positive. So that is not true, because f prime of minus 2 is actually positive. That means it's greater than f prime of minus 1, which is 0. But now the question says, which one is the answer? Obviously D, because we've successfully eliminated the others, has to be the correct answer. But how do we then justify all of these things? Well, we will see that basically, what we can say here is that the the most important bullet here is that f prime of 2 is equal to 0, right? Right. If this is the case, it concludes for us that x minus 2 is a factor of f prime x. This is using the remainder theorem. Not remainder, but factor theorem, sorry. Okay, good. So, what was key in answering this question was to appreciate this. And obviously, one could easily look at the gradients and then figure that out or whatever. So, this was very important to note. So, a little bit of theoretical knowledge is important, understanding factor theorem and what it means. If you substitute any value, whether you substitute a negative value into a particular function and you get 0, it means x minus, or should we say x together with the negative sign of that number will be a factor. Okay, it means that when you factorize that expression, this becomes one of the factors, essentially. All right, so that was easy, guys. Not a very tough question, obviously, but we're just trying to go comprehensive on how we answer these at the moment to enhance your sharpness. Otherwise, this is as easy as ABC. Let's move on. Question 54. We are told here that a line y equals 7x plus p is a tangent. So this is a tangent. Okay? 2. Now let's see, f of x equals k x cubed plus x at a point where x is minus 1. So x is minus 1 and some y value that we may need to find out. Okay, so we've got a point of tangency here. This literally is the point of tangency. Tangency, which I would like to introduce to you as the port. Okay, so what do we see? We are seeing a straight line and a cubic function because of the highest degree power involved in the expression. Fine. So this is a cubic function. Now this cannot be called a tangent in a situation like that, because we really do not have a tangent there. But I would rather the word local can be included, because it only can be a local tangent, but it can never be a true tangent. All right, so now what do we know? It says find the value of p, so we want to work out the y-intercept of this line. Well, we know two things here, that at the point of tangency, the port, there's two things that are of importance. One, the two functions have but maybe let's use it this way. They share the same point right? Which is the port. Whatever you say, guys, if it is something unusual, please introduce it nicely in an understandable manner before you use it. So they share the same point. At the same time, we know that the two functions also share, my share is crazy, the same, the gradient. So there's two things that are shared between the two functions at the point of tangency. They share the same point, which is the port, and they share the same gradient. So that means if we know the gradient of the other one, then we know the gradient of the other function as well. So there's a point and the gradient issue. So what does that mean? We then can appreciate here that therefore, in this case, if we take our function f, we understand that the first derivative at minus 1 of our function f should be equal to the gradient of the line y, which is going to be 7, because the gradient here is a 7. Okay, so I'm moving fast, guys. So this implies if we work this out, we get 3kx squared plus 1 is equal to 7. This implies that we've got 3k. Now why did I put x squared here? There's no need to put the x squared here. This is 1. Okay, maybe let's rewrite this nicely. So we know that this is going to be 3k. Instead of x, we put minus 1. We square that, plus 1 equal to 7. Certain actions, guys, you need to move quick. You can't be a baby about them. There's just no way. So 7 minus 1 is 6. Therefore, k is 2. Can you see? If k is 2, this implies that a is greater than 0 in our expression. Now, if a is greater than 0, it already tells us that the shape of our graph is of this nature. It's effectively an increasing function, but with just those local limitations there. Okay, so this is the idea we get, guys. So now we need to find our point of tangency because we can't sort that out. We could use the nature of the roots if this was quadratic, but with the cubic function it's a bit difficult. So we can say here, therefore, what can I say? We can say then the port is such that what? The port is such that 2k x, what am I doing now? 2x cubed plus x. Why did I do this one? Okay, so that means f of x is equal to 2x cubed plus x. Now with the port here, which is minus 1 is to y, is going to give us y equals 2. Instead of x, we put minus 1 cubed plus into minus 1. Therefore, y, maybe let's not rush. Say this implies y. This is minus 1 times 2 is minus 2. Minus 2 minus 1 is minus 3. So therefore our point of tangency is complete now. Okay, great. So after this, we can say then y equals 7x plus p with our point of tangency complete. Minus 3 is 7 into minus 1 plus p. Therefore p, remember this is minus 7. When we transpose it becomes plus 7. Plus 7 minus 3 is 4. Okay, so that is the value of p there. Okay guys, so this is one of those questions in the standard exam where you are given information about the tangent and the curve involved. Then one has to either work the equation of the tangent or whatever is necessary, or the point of tangency. So this is nothing out of the ordinary. Okay, but now the question is, does this make sense? Yes, it does, because the key here is substitutions. So let me just write here for you guys to make sure you understand these things. So what is key here is correct substitutions. If you don't perform correct substitutions, this becomes a horrible situation. Okay, now let's imagine, just for heaven's sakes, just for completeness sakes, what does this sketch look like, so that we can really prove that our pot is truly relevant? Because at some point, for us to be sure that this is the case, we need to prove that the pot is also correct. What does the sketch of this graph look like? Let's draw it over here. So obviously we're going to have the Cartesian plane as we know it. We've got x, y, origin. Now, if we look at this graph, how do we work out the x-intercepts? Now we look at that graph. For x-intercepts, this is going to be 2x plus x equal to 0, common factor. This is 2x cubed. This one becomes 2x squared plus 1 equal to 0. So we can appreciate that x is equal to 0, or we cannot have a situation here where 2x squared is equal to minus 1. So there's no solution here. Obviously, the discriminant of this quadratic factor is less than 0. So let me write it so that you can see. There's no way that a perfect square multiplied by a positive number can give us a negative answer. So this is not possible. So it means there's only one x-intercept, it's 0. Okay. Now we know the shape here. What should the shape look like then? It means it's coming to cut here, and then what happens now? Do we have a turning point? How many turning points will we have? Well, if we can include some stuff here. So for the turning point, we know that the first derivative of our function must be equal to 0. When we do that, we get 6x squared plus 1 is equal to 0. Again, in this instance, the discriminant is less than 0. So what does that mean? We will not have a situation where 6x squared is equal to minus 1. That means we don't have a turning point in this expression. Is that so? Yeah. Wait a minute. Yeah, we don't have x-intercepts here. So if we don't have x-intercepts here, what does that mean? It means this graph, this point becomes also the point of inflection. So this point becomes a turning point as well as the point of inflection, because for this shape to be valid, it means our graph is doing this and then it's turning. Okay, so this is the shape of our graph. So it turns here at the origin. So the point at the origin is both the turning point as well as the point of inflection, because our first derivative function is basically having non-real roots, and obviously that would mean, remember, this will have a minimum value of 1 when we see this. So the first derivative function was doing stuff like that. Can you see? Its turning point becomes the point of inflection. Okay, great. So now let's find this tangent. Remember, we had a tangent to deal with. So let's see. This tangent is when x is minus 1. So let's see. Let's pretend this is here. Okay, I mean the shape of our graph determines the stories. So let's see this. Can you see why I always make noise that this cannot be called a tangent? Because look at the point of tangency here. Say it's that point. Now we will appreciate that if that is minus 1, we found that P is 4. Can you see it's also positive here? So, and can you see the corresponding is minus 3. So technically, this speaks sense that our graph is complete. Obviously, guys, these other things were just additions. They were just additions so that we can do some justice to what we have done. So these are ways you can prove that what you did actually makes sense graphically, because if it does, then it means these values are correct. But again, you need to draw a sketch that is near a perfect sketch, because a totally rough sketch may give you incorrect information. So this is why I always assume a near perfect sketch so that I can be able to make proper deductions from it. So I hope you understand what is going on. So guys, we found out P is 4. That is done. All right, so therefore the answer to our question was option B. All right, so that's good. Let me just drink some water. Okay guys, so we can see that technically when we do everything nicely, it looks right. Okay, so this is what we call the mother function, okay, in a cubic function essentially. In fact, I just noticed something here. In what we just wrote here, we don't even need to transpose the 1 here, because sometimes you may ask yourself, why am I transposing? I know that basically 6x squared plus 1 cannot be equal to 0, right? That very expression, by inspection, you know that this is a perfect square. This is more like the vertex form of a quadratic. Can you see x can be any real value? That is a negative number. It will always come out positive because of the square. The number that we are multiplying this to is also positive. And the number that is being added is also positive. So there's no way that that expression can be equal to 0. Then this means there are no real roots here. Okay, so a few things, guys, to keep in mind as you work through these problems is very important. Obviously, this is when you're practicing. Guys, I will emphasize this. When you are practicing, don't worry about time too much, okay? When you're practicing to build your knowledge base, your abilities, to strengthen your efforts, don't apply time to that. You're going to waste precious time, because you'll be good in keeping time, but you'll keep time when you literally are not gaining anything from what you are doing. So you'll keep running in circles until when Jesus comes. Don't do that. Practice, take time. Take time to practice effectively. Do all of these things I'm doing here. It looks like it's a lot of work, but believe me, when this thing becomes second nature type of knowledge in your brain, you can perform a lot of gymnastics in a flash of light. I promise you. And that means when you get to that exam, you're going to win. 2, there's no point in practicing to keep time when you still have to practice to keep the knowledge, right? But when you are preparing for an upcoming exam, this is where practicing to keep time becomes important. But it becomes even easier when the knowledge is flowing, because you're not going to be struggling that much. Okay? In fact, you will hardly struggle. So you will not fail to keep time. That I can promise you. So know how to practice properly, guys. Don't practice and pressurize yourself at the same time by keeping time. You're not going to succeed. Believe me. Do it only to your own detriment. But if you practice to increase your knowledge, to make sure you're comfortable with some hectic stuff, then when the exam is coming, maybe you can say within 2 weeks of your exam, then you can practice keeping time, knowing very well that you are comfortable with most of the work that is about to be examined. Then that becomes an important thing to do. But don't do it from the very beginning. It's not an effective way to do things. All right, guys, before I say too much, we don't have much time, so let's go on. So 57. We are given here the graph of function f is shown here, right? So you can see this looks like a W. So once it looks like a W, we know this is a Quartic function. So this is a Quartic function, meaning the highest degree power here is, we can say ax to the exponent 4 some other terms. Okay, the other way you can look at it is that we've got how many turning points? 1, 2, 3. But this is an x-intercept. So when an x-intercept is also a turning point, it means there's equal roots here. So that means we've got how many roots? 1, 2, 3, 4. So we've got 4 roots. The reason is we've got 4 roots. Roots are basically x-intercepts. So with equal roots here, there's equal roots at x is equal to 0. So we count that for 2 roots. It's 1, 2, 3, and 4. So if we've got 4 roots, we know this is a Quartic function. The highest degree power is in the order of 4 in that expression. Okay, we don't care about the others. All we care about is that. All right. Great. Now, we are told here, for how many values of k will f prime of k? Can you see? F prime of k be equal to 0. So we know that the first derivative function to begin with speaks about the gradients, right? And we are saying the gradients now must be equal to 0. When are the gradients equal to 0 in this graph? So we know that the gradient at the turning point is 0, 0, and 0. So how many turning points do we have? 3. So for how many values of k in this expression, will we have the gradients being 0 at 3 positions. So this is as easy as that, guys. You don't complicate your life. So can you see a very solid knowledge of anything we have above? Even if we meet a graph that we don't understand, but by just seeing this is a curve with turning points, we can actually use our knowledge to work out any problem whatsoever. All right, so that is it, guys. So here we can appreciate that f of x is basically some a value multiplied by x to the exponent 4 and some other terms. How do we know this? We know this because it has 4 real roots with equal roots at the origin. How do we know this? Because this x-intercept is also a turning point. Okay, great. So we know that essentially the first derivative function is going to be 4 is going to be equal to 4ax cubed, and of course plus some other terms. So this means this is cubic, and we'll have 3 real roots at least. Obviously we don't know, but we can appreciate that. So there's many ways of killing this cat. We can look at the fact that the first derivative function becomes a cubic function from a quartic function. We know when we differentiate a quartic function, we get a cubic function. A cubic function will have 3 real roots at least. Will have at least 3 real roots. Maybe let's not say at least, but at most, because it's either it's 3. Remember this statement here, at most, means less than or equal to 3, right? So yes, it will at most have 3 real roots, but they can be 3, they can be 2, can be 1, or they may not exist at all. But have you ever seen a cubic function with no real roots at all? You will never see that one. There will always be at least 1 real root. So for a cubic function, the number of roots can either be 3, 2, or 1, but they can never be 0 for a cubic function. There's no cubic function that has 0 real roots. I have never seen one, or at least I cannot imagine one. Anyway, guys, so that is the story here. So that is why we understand what we understand. So basically k is the x values here. So k represents the x-intercept. So we can say therefore k represents the x-coordinates of the x-intercept. Represents the x-coordinates of the x-intercepts of the first derivative function. So what do we say? Therefore the answer to this question is option C. It's the best answer, obviously, and technically because we can see that exactly on the graph. So understanding what the first derivative function of any given function represents is important, and we'll say gradients must be 0. They are 0 at that turning point, and that, and that. So there's only 3 areas where the x-coordinate gives us a first derivative function of a value of 0. Okay guys, masiqhubeke sesimoshe ixesha manje. This is 17. Now it says which of the following equations could be the equation of the given graph. Now we see something curving like this. So obviously this is approaching some imaginary line here. We can draw a line that it seems to approach. Okay. Also we can draw another line that this graph seems to approach. Okay. So what are these lines? We can say these are possibly asymptotes. Because this line seems like it's going to go straight from here. It will not intersect. And it's going straight. It will not intersect. So there's two possibilities for this question here to consider. We can either decide there is no vertical asymptote but a horizontal asymptote. This could be an exponential equation or exponential function 1. This is the exponential function. Okay? Or maybe, let's write this one first. This could be a restricted hyperbolic function, such that obviously we can see that this asymptote would be somewhere between 3 and 2, effectively 2,5. So we can say here where x is less than the vertical asymptote. Vertical asymptote. Okay. So that would be the restriction for this possibly a hyperbolic function, because we know we would have this graph here and then another graph there. But this would be values greater than the horizontal asymptote. So this one is missing. Or this could easily be an exponential function. Okay. Here there's no restriction per se. Now such that, look at this. We can see that if this is an exponential function, therefore this becomes the horizontal asymptote. Because in an exponential function, we only have one asymptote. It is the horizontal asymptote. So the best position to draw it is over there. So we can say here with this exponential function, we've got our horizontal asymptote. Such that y equals 3. Not 3, but 2. Okay. And what else? We see that this graph appears below the horizontal asymptote. So what we can appreciate is that technically the a value is less than 0 in this graph. Why? Because the graph is below the horizontal asymptote. So when the graph is below the horizontal asymptote, is below the horizontal asymptote. Okay, all right, okay. Now, that is fine, but now look at this. This graph is decreasing. The graph is decreasing. So what does that mean? If the graph is decreasing, it means here we've got the base of this graph, of the actual power, the base is greater than 1. Why? Because the combination of the two ticks the boxes for that description. The decreasing nature of this graph is given by an a value of less than 0 and a base of our exponential expression that is greater than 1. Siyabangena ke manje. As for the x-intercepts and the y-intercepts, don't matter. Okay, not a big deal. So this one is winning. Why is it winning, guys? Because we can see that in the options, all that is described is exponential equations. So that is why it wins the race. So that means we have to focus on this. Now, the question says, which of the following equations below could be the equation of the given graph? Now, we know that a is less than 0. So a is less than 0, less than 0. So technically these ones, a is greater than 0, so they are already out. Elimination technique. Now we've got to dance with the 2. What else do we realize? The horizontal asymptote is 2. So again, these ones are on equal footing for that. Now what else must we do? We can see here that technically we need to think about the x-intercept is at 1 and 0. Now let's work out this x-intercept. X-intercept means y is 0. So let's see. When y is 0, we get minus into 2 to the exponent x plus 2. We transpose the 2. We get okay, let's just not do this. It's too small, the space to write in. So now let's look at this x-intercept for each one. So when we take the other one, we get 0 is equal to minus into 2 to the exponent x plus 2. This implies minus 2 is equal to minus into 2 to the exponent x. When we multiply by negative, it means 2 to the exponent 1 is equal to 2 to the exponent x. Therefore, x is equal to 1. So this means it ticks the boxes for the x-intercept of 1. Okay, what about this one? 0 is equal to minus into 3 to the exponent x plus 2. This implies minus 2 is minus into 3 to the exponent x, which implies that 2 is equal to 3 to the exponent x. And obviously here the bases are not equal. So we know for a fact that in this case, x is not equal to 1. At least we can say that. So that means this one is inadmissible for being a possibility. Inadmissible. Let's just say not applicable to avoid troubles. So now this one fails the test when it comes to the x-intercept. So it came very close, but not close enough. So what is our answer here? Is A. So therefore, answer to this question is option A. Alright guys, so you can see here there is a lot of things to imagine. Let's say, for example, we wanted to test the y coordinate. Would it be satisfactory? Yes, of course, because if you look here, x would be 0. Any base to the exponent 0 is 1. Minus 1 plus 2 is 1. So the y-intercept here is equal to 1. Here, we put 0 there, we get any base to the exponent 0 is 1. Minus 1 plus 2 is 1. So the y-intercept is equal to 1. So can you see? The y-intercept is the same for both. The difference is the x-intercept. So this one was a very strong candidate. Like the DA at the moment, if we are going to talk politics. Anyway, guys, let's move on. Giving you some extra notes so that you can appreciate a few things here. This video is becoming longer than I wanted, so we will have to chop it quickly now. The graph of the function f equals ax squared plus bx plus c. Okay, shown below. Choose the correct information. Okay, great. About the values of a, b, and c. Okay, c is literally the y-intercept. So this means this is c. So we can see c is greater than 0. A is the coefficient of the highest power. It means since the graph is concave down, a is less than 0. Okay, so we can appreciate c is greater than 0, a is less than 0. Then the question is b. Now if we look at the axis of symmetry, axis of symmetry here is on the positive x-axis with the origin there. Right. So what does that mean? Now we know a is less than 0. Then it means b must be positive here. So it means b must be greater than 0 by inspection. Okay, let's just quickly go through these parameters here. So I'm not going to say this is the standard form, right? This is the standard format of the graph. So from here, we can appreciate that a is less than 0 because the graph is concave down. 2, we've established that b is greater than 0, but how do we know? Because we know minus b over 2a is greater than 0 over 1. Now, there's something that we know. We know that the a value is negative. So this means this entire expression here, this entire expression is negative. So a negative divided by negative is positive. So that means b over 2a is greater than 0 over 1. Then we can cross multiply. Now remember, this has been transformed now into a positive thing. Now once we know the characteristic of that denominator fully, we can do cross multiplication. You can see that b is going to be equal, it's going to be greater than 0. So with inequalities, you need to be very, very, very careful. They can throw you under the bus to die. And obviously c here is greater than 0. So what is our answer here? A less than 0, b greater than 0, and c greater than 0 is option B. I don't want to say more here. Let's just move on. We are already applying what we have learned. So 30 says the graph of f equals ax squared plus bx plus c. Again, we see a standard parabola there. I'm not going to say any more. We've been saying a lot. Now here's a turning point at -2:4. So now, is this a maximum turning point or is it a minimum? Is it a maximum or minimum? Well, we don't care. All we know that this is a parabola. So with a parabola, remember this is hypothetical, so we don't know. But look at this turning point. The y value at the turning point is a positive number. So we've got a position of this turning point. Let's put it there. So we've got a possibility that this graph looks like this. Maybe let me not do this. Let me just draw the sketch first. This graph could be like that. Maybe let's not. Let's just draw a proper graph. It could be something like. So basically, guys, this is the sketch that we can draw. There's two possibilities. This graph could be concave up. It could be concave down. So obviously, if it is concave up, it means it has no real roots. If it is concave down, it definitely has real roots. Okay. So obviously, if we knew something about the discriminant, we would know exactly which shape to consider. Okay, that's not a problem. Now, we are asked a question, which one of the following functions will be equal to 0 for exactly one value of x? So this statement says only one x-intercept. And that means the x-intercept is also a turning point. Because for a parabola, remember, the highest degree power here is in the order of 2. So it means for us to have only one root, because when we say it is equal to 0, this is essentially saying at the x-intercept. So when we're saying one value of x, we are suggesting we now have to do something about our graph so that we only have one root, meaning the x-intercept must also be the turning point. So let's look at this one. Now can you see these are all transformations? So all of these options are literally, these are all transformations of f of x. Can you see? Y equals f at x plus 2. This is a horizontal translation of this graph by 2 units to the left. This is f of x of minus x. Once we do that, this is basically a reflection of our graph horizontally or about the y-axis and shifting it upward by 2 units. Now this is essentially a right horizontal translation of f by 4 units. This is basically f of x shifted down by 4 units. So let's see what must happen here. For us to have only one root, there's only one direction we can move our graph. We have to move it down to the x-axis. So if we move it down to the x-axis, it means this graph is either going to look like this, because we still don't know, or it's going to look stuff like that. So technically, to have one root, it means we need to move it down by 4 units. So this is a correct transformation, and literally we didn't change the f of x, whatever it is. So what can we say here? What is key here is knowing how to perform transformations of any given function in any manner required. So that is just the key piece of info here. If you know how to perform a transformation, okay, this is what is important, is knowing how to do transformations in any manner required. Honestly, in any manner required, because some transformations are even more weird than you would expect. The usual is the horizontal left or right, is the vertical up or down, is the reflections, which is horizontal or vertical, or inverse is about the line y is equal to x. So, but sometimes you are given a line that you never expected, and you are supposed to reflect a graph about that particular line. It can be any line, oblique, vertical, horizontal, whatsoever. So that is what I'm trying to suggest here. Be able to perform these things. Again, understand the statements provided to you. Be able to do some form of graphical depictions of your sketches, because that way it becomes a very good aid in giving you a clue of what is expected in you, or at least to perform, to answer the question much more appropriately or effectively. So I like this question. It's a good question. It's a good question because it really forces you to think outside the box. Anyway, let's go on, guys. Yeah, there's still more functions. Let's move. 31 says, choose the incorrect statement about the graph. So now we don't want the truth, we want a lie. Y equals f of x. So what is it? When you look at the shape, it is mostly a cubic function. So this is a cubic, at least it's a cubic function, because we've got 3 roots here. That's why I know it's a cubic. There's 3 roots and 2 turning points. So this is just a crude way of looking at it. So we've got 3 roots and 2 turning points. Okay. Now let's see. And of course, it's the positively considered one, or it's a positive one. We always consider this a positive because this is effectively an increasing function. Just that section which is limited by the local maximum and the local minimum. All right, so now we know that f prime of 0 is less than 0. Yes, that's true. Because when we draw a local tangent at the origin, we can see that the slope of that tangent is negative. So this is true. So we don't want true information. And then f prime of minus 2 is greater than 0. That is true because, again, if we draw a tangent right at that x-intercept, if we draw a local tangent at the x-intercept, what can we appreciate? We can appreciate that the gradients are positive there. So that's greater than 0. That's true. F of minus 2 is equal to f of 0 equal to f of 2. Yes, that is true because these are the x-intercepts. So at the x-intercepts, the graph is 0. And all of those give us the same answer of 0. Now f of minus 1 is less than f of 2. Okay, f of 2 is 0. But f of minus 1, you can see it's positive there. F of minus 1 is positive. And yet f of 2 is 0. So this is incorrect. And therefore, it becomes the answer. Because we are looking for the incorrect answer here. Okay, I don't think there's any notes for me to give you guys here. So perhaps we can just say here f of x is a cubic function. Is a cubic function. How do we know? Because we've got 3 roots and 2 turning points, and perhaps we can also tell that the coefficient of the x cubed is positive, it's greater than 0. And that's it. Otherwise, guys, here there isn't really much. So the answer is really vaguely connected to option D. That's when we just do our graphical walk through. So there's nothing fancy to say here, or any notes for that matter. The graphs of the linear function f and the quadratic function g. So we've got a linear function f and the quadratic. So this is f, this is g. All right. Now it says for which values of x is f of x times g of x greater than 0. So meaning the y values of f multiplied by y values of g must be greater than 0. Okay, so this question, when we have this f of x times g of x less than 0, this implies that we are saying y values of f times y values of g must be less than 0, meaning a negative number. Negative must be equal to, in fact, let me write it like this. This must be equal to a negative number. Oh, negative. Oh, run away. I don't know, man. At some point, my time just gets chowed by just wanting to write everything. Okay, that's it. It's better. Along the edges, it's not so easy to write. The S Pen actually just misbehaves. I noticed that now. It's not me, but it's the thing. Okay, so these are one of those questions, part of the function related questions in your standard exam. So let's look at it. Okay guys, look at this situation over here. What can we appreciate from this sketch? Maybe let's choose a much more nicer color. So we need to find the values for which, when we multiply the y values of the straight line together with those of the quadratic, we get an answer that is negative. So what do we see? If we start from this x-intercept, remember this is 2 right here. This is 2. So if we say, well, at 2, obviously they are both 0, so 0 is not included, so it's an open circle. So going in this direction, is that going to give us what we want? Remember, this graph is positive and that graph is positive. So this is a forbidden path. No one must walk this route. It goes to the danger zone. All right. Now let's see, between 0, again, is 0 included? By the way, the answer is Well, these two are equal and they are both negative. So negative times negative is an answer that is positive, so we cannot include that. In between, these two graphs are both negative. So again, this situation over here is a forbidden path to take. Can we consider this x-intercept? Obviously, this graph is 0 there. This is at 1, okay? Now, if it is 0, in between, the two graphs are both negative. So again, it's a forbidden route. Can we go below that -1 there? Yes, because this graph is positive here, and then this one is negative. So a positive times negative is basically less than 0. So our answer is to say x must be less than 1. Okay, so this question is the easiest. When you are comfortable looking at the graphs. Obviously, I'm just walking you through it section by section, but for you in the exam, you don't need to be coloring anything. Take your ruler, put it across here, focus on the side of the ruler, then you move your ruler to that side and focus on that segment. Does it make any sense? You move your ruler between here to there, then you focus on that segment. Does it make sense? And so forth. So always choose some identifiable points that you can use as your reference points. What matters here is reference points, or should you call these critical values. Then you look before, at, and after that critical value, and you keep doing the same until the answer is complete. So there's nothing much to say about that question, really. 44. Now 44 says the graph of f is shown below. So again, we can see here, for which values of k will the equation, okay, f of x equals k will have 3 distinct roots, okay? So basically we are saying 3 unequal x-intercepts. All right, so now we can see there's 2 graphs that are equal. So we are given 2 functions here. We've got the function y equals f of x. Let's put it that way. We've got y equals f of x, and y is equal to k. So we can see that this is a horizontal line, and this is cubic, looking at the sketch, because this is the graph of f. So this is f. Now we are saying any horizontal line. Can we draw it here? Yes, we can. This is when k is less than 0. Right, maybe let me write here. This is the line y equals k, where k is less than 0, because this is where it cuts the y-axis. Is it going to work? Well, let's see. The other very important area to focus is along the x-axis. So this is still the line y equals k. This is where k is equal to 0. We can think of a situation where we draw this line over here. This is the line y equals k. This is where k is less than 3 but greater than 0. Okay, because it's in between the 2 maxima and minima. And then we can draw another one here, right at the maximum, or right through the maximum. So this is the line y equals k. This is when k is equal to 3, right at that maximum. You can also draw another one. and say, what about we draw this line over there? This is still y equals k. This is when k is greater than 3. Okay, we don't really care. It's cutting at 4, but we just want regions more than actual values per se, but some critical values are to be considered. So when do we see this line of ours intersecting the graph? 3 times. This one only intersects once, so that's not correct. This one intersects twice. That's not enough. This one intersects 3 times, and that's what we want. This one intersects twice. That's not quite. This one intersects once. That's not quite. So where should our k be? K must be less than 3. So here we can just say answer must be less than 3, greater than 0. So easy, 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 easy. There's nothing really much to say here. Answer is A. So it's always easier when you have a horizontal line doing all these things. So here we just literally want the points of intersections to be 3, because the roots, when 2 equations are equal to each other, they are literally the points of intersections. All right, so this is very easy. Let's just keep moving, guys. Hopefully we will be able to keep time. 46. In the diagram, shows 2 tangential circles with their centers on the x-axis. Okay, so we can see these are the 2 circles. There's a center there. There's a center there. And these circles fit within a larger circle defined by that. So this is the bigger circle with the center at the origin. So the center there is at 0. Okay. If the radius of the smallest circle, now this is a statement to watch out for. The radius of the smallest circle is half the radius of the middle-sized circle. Find the equation of the smallest circle. All right, so this is more like analytical geometry here involving circles. Okay, now we need to understand 2 things here. Understand 1, we need to understand ratios and proportions. Ratios and proportions. What else must we know? Knowledge of all functions. Okay, we need to know all functions, circle, straight lines, whatever. Okay, this is important. So make sure this is very clear. So how do we begin? We can see this is the circle with the center at the origin. Now the square root of 144 gives us 12, so it means the radius goes to 12. Even the y-intercept will go to 12, minus 12, minus 12. Okay, so that's fine. So this means this whole line here is 12 units. That's great. But then if the diameter, so when we are given this, if maybe let's write it this way. Given that RS for the smaller circle is half the radius of the medium circle, how do I write it? You can say R of the smaller circle is basically equal to 1/2 the radius of the medium circle. Okay, that is given. It follows, therefore, that technically the radius, we can say 2 times the radius of the smaller circle would be equal to the radius of the medium circle. I'm losing time. And if this is the case, this means basically 2 times the diameter of the smaller circle is going to be equal to the diameter of the medium circle. Okay, for me this is much better because it's easy to divide that distance into these diameters. Because, for example, if we say this is the diameter of this circle here, and then we say this is the diameter of that circle there. So if we call this one A, if we call that one A, this means this one is going to be 2A. Okay, so it's very important to know this. All right. So we can say here, let diameter of the smaller circle be equal to A. Okay, that is great. And then we know now that then it means 2A plus A is going to be equal to the square root of 144, because we can see that those distances added together, they give us the radius of this bigger circle. This implies that 3A is equal to, this is 12. Therefore, A is 4 units. Can you see? We found the diameter of this circle. So what does that mean? It means that point right there, that point on the circumference is 4 units back from 12. That would be 8. Okay? Because it means the diameter of the bigger circle, of the middle circle, is going to be 2 times 4, which is 8 units. Okay. So now we need to find the center of the small circle. We need to find the center of the small circle. It's going to be, remember this is the diameter, it's going to be the average. So it's going to be 12 plus 8 over 2, which is 10. So we know that the center is at 10 and 0. So basically that's the story there. Should have written it properly here. Okay, so this is what we've got. So now we were only interested in the center of the smaller circle. So we can say essentially then the center what did I write here now? Center of the smaller circle is going to be given by, now we can see here, that's going to be the value there and the value at the end. So the value there was basically 4 times 2 plus 12 over 2 and 0, which is going to give us 10 and 0. We can say therefore the equation of the smaller circle is going to be given by x minus 10. Remember, this is positive all squared, plus, now this is y minus 0, which is just going to be y squared, equals, now remember r squared, half of 4 is 2. Then obviously the diameter, okay, let me think again now. R squared is going to be half of this diameter, which is 2. 2 squared is 4. So this is 4. Okay, we are done here. So that makes it option D. Alright, so a little bit of analytical geometry here. So again, knowing how to, perform some formidable, is it formidable? I don't know, man. Let me not speak too much English. I'll say stupid things. This English, it's gonna cause problems, my friend. Doch, masiyeke, singekabhudi. Now, that is done, guys. So again, one needs to know how to use a little bit of logic here and there, integrating topics here and there. And you can see why we study all these functions and all these geometric shapes and the Cartesian plane. Now we can make sense of a lot of complex situations by just using these little small tools. So understanding some ratios and proportions is important, guys. And yeah, this is essentially analytical geometry, if you did not notice. Okay, let's move on to the next question. So here, therefore, the answer to this question is D. All right. So let's look at this 44. We've been hitting 44s for a while now. F of x is equal to sine x. Okay. So what is this? This is the standard sine graph. Okay. The standard sine graph, what do we know about it? Well, we know that the amplitude is 1 because there's an invisible 1 here. So which is the coefficient of the trig ratio here? It's an invisible 1. So this means amplitude is equal to 1. Then it means our maximum is going to be 1, which also implies our minimum is going to be 1. Sorry, not 1, but minus 1. All right, that's fair. And then we say that, look, the angle itself has an invisible 1 also as a coefficient. I don't know how to show this. So if this is the case, it tells us that the period t is going to be the original period of a sine graph over that coefficient, which is 1. And that gives us 360 degrees. What does this do? It gives us intervals on which to make sure we capture the critical values on the sine graph. When we want to draw it fast, intervals is always period t over. Now remember, this is the current period. It's not just any period. It's the current period in the given function divided by 4. And again, you must know very well that the 4 represents the 4 quadrants of the Cartesian plane. So we can even label this one and say this is the current period of the function. This is the 4 quadrants. What can I say, Baba? We can say these are the quadrants. Come on, little thingy man, some Portuguese. Quadrants, of the Cartesian plane. How do you write Cartesian? Balwa kanjani Cartesian plane nina man? Kaningixelele sendimlibele. Because we know there is always a single defining moment in the first quadrant, single defining moment in the second quadrant, single defining moment in the third quadrant, single defining moment in the fourth quadrant for each one of these functions, especially sine and cos. So guys, this is knowledge that you must have. Obviously, this means intervals. Masibhale uzoyazi nayo uba yintoni le. This is intervals. So if you want, it's the spacing on the graph. So you want to make sure you space the graph in terms of degrees so that you capture all the critical values. You don't want to lose them. Okay, so now the question says g of x is cos of that story. And essentially, we have g. Okay, we've got f and we've got g of x is equal to cos of x. Okay, then similar parameters, I would just say similar parameters. Ne? These are similar parameters. So I'll just say has similar parameters as f of x. So that means the period, we can say the amplitude is the same. So maximum is going to be 1, minimum is going to be -1. And essentially the period is going to be 360. When we divide that into quadrants, we get the spacing of, I didn't complete this story, guys. How can I do that? Now I'm becoming a hooligan. So our intervals are going to be 360 degrees divided by 4, which is equal to 90 degrees. Okay, masikubuyisele ke ngoku endaweni safe. So we need to know all of these things when we are given a function. These are things you want to do on the side and be sure you are comfortable, so that if you have to draw the graph, you go for it. Okay, now a sine graph would look something like this, literally. But this is essentially a very fast sine graph, isn't it? Yeah, it's not true, this one. It's wrong. It's not right, because this one is doing things that we don't like. It's too quick. The standard sine graph is like this. So basically, guys, a standard sine graph would look like this. Can you see how nice it is when we do the intervals of 90? We don't lose on the shape and the critical values. Critical values being an x-intercept, turning point, x-intercept, turning point, and so forth. Okay, so we can see that a single sine wave here is this one. Can you see it's complete from 0 to 360? So that's why we say the period is 360. Okay, great. That's what we need to make sure is clear. Okay, guys, so again, like I said, that the cosine graph will have the similar properties. So again, it has the spacing of 90 degrees, and we can see we don't miss the graph if we draw it for the same stories there. So literally, if you look at this graph, you will see that from 0 to 360, the cosine graph has completed a full cycle. That's why we say the period is 360 for sine and cos. Okay, so this was just to give you some notes, guys, and also points of reference, given some pieces of information. Can you see, this is why this gymnastic here is so important in identifying those areas, because to draw the graph is just, an effortless exercise. Now the question comes and says, now, which of the following is the graph of, of f of x multiplied by g of x? Now, what on earth is that? Okay, guys, let's look at this now. H of x is going to be f of x times g of x. So this means this is sine x times cos x. So essentially, what is that? Now, that means we need to think outside the box. Now, when we see cos multiplied by sine, this should remind you and I of double angle identity of sine. So we know that, however, we understand that sine 2x is essentially 2 sine x cos x. So how do we isolate those guys? We literally divide by 2 on both sides. So this implies, as a result, that essentially sine x cos x is just a half of sine 2x. Now, just a moment. Okay, so in actual facts, guys, we can safely say h of x is therefore equal to the half sine 2x. This is what we can come to. So always, guys, remember your trigonometry. Now look at that. The amplitude is a half. So this means our max is going to be at a positive half. Our minimum is going to be at negative a half. Great. Great, 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 great. Now look at that. The coefficient of the angle is a 2. So what does that tell us? It tells us that the period is going to be the old period, the sine period, divided by the coefficient of the angle, which becomes 180 degrees. So this means this sine graph is going to complete a full cycle at 180. And then obviously this tells us that our intervals are going to be the period, which is 180 degrees divided by 4. Now 180 divided by 4 is 45 degrees. Nice and easy. So that means on our graph the spacing is 45. The maximum is going to be at a half. The minimum is going to be at a minus half. And the period at which a cycle is completed here is going to be at 180 degrees. So now the question says, which one of the graphs represents this? Now we can see here, this one goes to a maximum of 1. Already the maximum is wrong. We look at B, we can see the maximum is roughly at a half. So the maximum is correct. Let's look at the period. When is the sine graph completing? From 0, can you see it's a full sine wave at exactly 180. So for the period, it's also correct. And is there anything more we need to do? Not at all. So this becomes the true graph, because this one is a cosine graph. This one is a cosine graph. Can you see it starts with a maximum of half, but again this is the cosine graph, this is not the sine graph. Okay, so the wave is not doing it. Remember the starting point is 0, so at the starting point 0 the graph must be at 0 for the sine graph. Remember the starting point is 0, so it starts at 0. So this one starts at a maximum already. So this is the cosine graph. As you can see, the starting point was already 1. Okay, so that one is wrong. This one is wrong. So the best answer here is B. So this is how, guys, you work these things out. Obviously, this is all effortless when this knowledge is cemented in your brain. This is what happens. So can you see, guys, at times you must never forget identities. So note, when it comes to trigonometry, note the 3-step approach. How do I write this word? Note the 3-step approach. Approach in trigonometry. Because if you don't remember this, remember the 3-step approach is BODMAS, factorizations, and identities. So therefore here the answer for this one became option B. Okay, guys, so obviously this thing is taking long, right? Right. But consider this some course on NBT. I mean, you're not gonna sit down for 30 minutes and understand all of what you need to do. At the same time, I'm not here for enticing you with the answers and showing you how smart I am. I'm trying to make you smart too. That's the idea. I'm not here to display my abilities for you to be impressed, but I'm here to share the knowledge so that you become better than me in fact. Anyway, let's just go. 52 says, given the diagram below, so this is now Euclidean geometry. Some of you are writing this tomorrow, so I hope you will see some of the things you need, if at all they will be applicable. You never know. Use the given diagram with circle center O to find the size of x. Okay, great. So with Euclidean geometry, guys, you work on the diagram, right? I cannot overly emphasize that. If you don't, then you are not serious. So these are ready. So if these are ready, they already create isosceles triangles. So that means that angle equals that angle. These are the angles opposite the equal sides in a triangle. So that angle is equal to that angle. Same story. Angles opposite equal sides. Okay, great. But now how will we find x? This is interesting if you ask me. Now let's look at these triangles here. So if we look at this yellow triangle, we can see that x and that angle c essentially will give us that angle BAC, which is the exterior angle of that triangle. Okay, but now how do we find angle C in this scenario? So if you notice here, you will see that angle C and that angle D, they are equal, but if we add them up, they should give us 50 degrees because that becomes the exterior angle of this red triangle. But now the other question says, how do we find that angle BAC? So same issues. If we look at this triangle ABO, we will notice that this 120 is an exterior angle of this triangle, with those two being equal. So we have to work with 3 triangles to get to the answer. Can you see? So these are usually the questions you guys get in Euclidean geometry. It's usually question what? 8 or 9. I think it's question 9 usually, where you get just a standalone question with multiple steps to solve a variable. So they either give you this kind of a question, or they give you some quadrilateral or any structure without a circle in it, and then you deal with it. Okay. Now we can see that we need angle C and we need angle A. So it doesn't really matter which one we start with. Let's start with the BAO or AOB. So we can say here in triangle AOB, we understand that basically angle, let's say BAC, is equal to angle B. B is at least an easy angle. So why? These are angles opposite equal sides in a triangle with radii OA equal to OB. Okay, so that's easy. But we understand also that essentially this angle BAC plus this angle B should give us angle BOC. Why? This is the exterior angle of a triangle. Same triangle we're speaking about. This implies, since these two are equal and we're interested in BAC, we'll just say twice angle BAC is equal to 120 degrees. Therefore, angle BAC is equal to 60 degrees. So we have found the angle of interest. So this is an intermediate answer, so we're not going to underline it. Now we want to look at the red triangle. We will say in triangle COD. What is the story here? We know that we're interested in angle C, so angle C is standalone plus this angle ODC. No. They are equal first. Then the reason here is because these are angles opposite equal sides in a triangle with radii OC equaling OD. Okay, that's great. We also know here, also we understand that angle C plus angle ODC is equal to angle AOD. This is the exterior angle of a triangle. We're speaking about COD this time. Okay. Now, since we said these are all equal to angle C and we are interested in angle C, we will say twice angle C is equal to 50 degrees. We can say therefore angle C is equal to 25 degrees. It's an intermediate answer. So we drive home now. We can say then in triangle we've got ACE, ACE. Okay, what is going on in that triangle? We understand that basically angle E plus angle C should be equal to angle BAC. That's the exterior angle of a triangle. We're talking about ACE. This implies that X plus 25 degrees is equal to, we found out above that BAC was 60 degrees. Therefore, our X is going to be 60 minus 25, that is 35 degrees. Answer. Now we can underline that. So what does that mean? The answer becomes option D. So essentially, this one you would just have to go with the flow. Understand the theorems that govern some postulations you need to make. At the same time, you need to be skilled enough to see all of these triangles. I'm highlighting them so that you can see. Obviously, a student who wants to become a doctor will just work here and be able to see things in this mix, right? But an engineering wired individual will always try to separate these so that they can see clearly. Because engineers, when you bring your car to them or whatever, they want to work on it in parts. As doctors, if you're a surgeon, you can't remove the kidney and put it aside and work on the veins or whatever. You have to shift things while they are still connected to the rest of the body and work efficiently there. So sometimes how you work these things out can even determine the type of a person you probably should be. Anyway, it's a pity we cannot look at these things and determine, because some of you will apply for medicine, right? And then in medicine, even a general doctor, general practitioner needs to know how to operate, to perform a cesarean section, that is to deliver a baby from a woman. When somebody comes stabbed in the community there, whether village or town, whatever, they need to be able to open the abdomen if it is injured or whatever. So remember, if you want to become a doctor, you do a course called MBCHB. The MB part is Bachelor of Medicine. The CHB part is Bachelor of Surgery. So you are doing 2 degrees at once. You must be a surgeon and a doctor. Okay, a doctor who can treat with medicines, a doctor who can treat with operations, and there's no excuse. So you should not be accepted into medicine if you can't work. I wish there was a way of monitoring, because we see a lot of these doctors who can't really focus, and they must not be there. Yes, they are smart, but you can see their wiring is not okay for medicine. Anyway, guys, again, I'm losing time. So 20, number 20, must feel like page and number 20. Excuse me for that. All right, so number 20 says, in the diagram not drawn to scale, PAQ is a tangent. So I often highlight things. You don't need to. But because I'm teaching you, I want you to be able to focus. To the circle center O, so this is the center at A. Okay, fine. So obviously this is going to speak some vibes of 10 chord theorem, right? So we can see the angle between the tangent and the chord CA or AC should be equal to the angle subtended by that chord in the alternate segment or its circumference. So that is the 10 chord here. And vice versa. We can also look at that this angle between the tangent and the chord should be equal to the angle subtended by that chord at circumference. Great stories. Now let's leave the tangent business because there's no radius reaching the tangent, so we don't have the tangent perpendicular to radius. Essentially it says PBC is a secant. Now a secant cuts through a curve or a circle at 2 points, and we can see that. And then we are told though that PB is equal to BA. Now that's great information. So PB, this one, is equal to BA, that line. So what does that create? An isosceles triangle. And in that isosceles triangle, we've got that angle equaling that angle there. These are angles opposite equal sides in a triangle. And we are told here that CAQ is 100 degrees. So this is 100 degrees. All right. And find the size of angle BOC. So the angle in question here is BOC, is this angle right here. That's the angle in question. But now look at this. This is the angle at center, subtended by chord BC. But chord BC subtends an angle at circumference, which is angle BAC. So we can say if this angle is 2 times that, then that one is just 1 tick. So we've got an angle at center equaling 2 times the angle at circumference. So that means the key to our problems is to find the size of angle A, or should we call it BAC? Because if we find BAC, we have literally found a way of solving BOC. So how do we start? Well, it is a very interesting situation that I am going to tell you stuff about. Look at this. Look at this yellow triangle, this isosceles triangle. What do you notice? This angle, ABC, is an exterior angle of that isosceles triangle, with those two angles being equal to each other. And that means we can use this angle to find this angle A on this side, which is PAB or BAP. We already have this one as 100, and these are angles on a straight line, so that means we can find BAC. After that, we move and move and move and move. So let's see. Let's start by defining this angle ABC. Using our 10 chord theorem, we know that angle ABC is going to be equal to angle CAQ. This is the 10 chord theorem. Okay, great. So therefore, our angle ABC is equal to 100 degrees. That's important. We will say also, we appreciate that essentially angle, we can say angle, okay, maybe let's not say also, we can just start by saying in triangle ABP, we will appreciate that angle PAB is equal to angle P. These are angles opposite equal sides, with BP, is it PB, with PB equaling BA. So we know that lead is equal to the Bachelor of Arts. Okay, all right. So sometimes this reason is not complete if you don't say certain things about it. We can say here it was given the fact that, now you need to write it for completeness sakes, obviously, but I know you guys are lazy and complacent, you will not do it. But what if someone forgot it was given? It gives you a wrong mark. Obviously this is not an exam that is marked by an individual. Thank God you are choosing the answer, so the computer marks you. So it means if what is inserted in the computer is the wrong answer, unfortunately it's going to be a wrong answer. If it is wrong, it's going to be the right answer even if it's wrong. Look at that question we did on the other video for NBTs. There was a wrong answer there. So that's a sad situation, because how do you correct what the computer does? And we forget that the computer only does what was inserted by a human being. So if it is wrong, the computer will recognize that as correct. So at some point, whatever seems to make things easy, it does not completely exclude problems. Anyway, guys, let's not talk too much. Now, what is the story here that we're trying to drive into? It is to say, in this particular triangle, we understand that essentially angle P plus this angle, say PAB, is basically equal to angle ABC. This is the exterior angle of a triangle. I think this exterior angle of a triangle thing is overlooked by a lot of people, and it seems to be quite useful. As you have seen, the chord theorem is so commonly useful. Even this thing is creeping into this field because I have always seen an opportunity to use this property of triangles. So you better equip yourselves or you're going to die. Now we are interested in this angle PAB. So if these two are equal, it means 2 times that is going to be this one. So ABC we found out above is 100. Therefore it means PAB is going to be 100 divided by 2. That gives us 50 degrees. Okay. all right, okay. Now, we have a big story yet to still tell. We must tell them stories, because if we don't tell them stories, what are we going to tell? Nothing. So we can say here, we understand then that basically this angle PAB plus this angle BAC, this is our next guy of interest, plus angle CAQ equals 180 degrees. These are angles on a straight line. Angles on a straight line are supplementary. We know that. We know that. A dot, my friend. You see, dot 1 is on. Now, what was CAQ? It was 100 degrees equals 180 degrees. I am not interested in a lot of things. 180 minus 150 is 30 degrees. We can say here, therefore, we understand then that angle BOC, the bulk, is equal to 2 times angle BAC. The bulk, you see, the bulk is equal to the bulk. Why? Angle at center equals to 2 times angle at circumference. Therefore, or maybe let's say this implies that the bulk is equal to 2 times the bulk, which is 30 degrees. Therefore, BOC is equal to 60 degrees. Voila! It is done. So what is this option right here? This option is option C. So we can make a conclusion that the answer to this question is option C. All right. So you can see, guys, multiple steps were to be included here. So I am showing you this is what is needed from you. Imagine, you may think that you can just guess the answer or just look at this diagram and get the answer. No, there's some time that needs to be banked on working these solutions. So unfortunately, guys, there is no way you are escaping that torture. And unfortunately, these math essay type questions are the ones you're going to come across this NBT thing. And not just the NBT, even the standard exams, you get questions like this where a single question forces you into a multiple step process to solve perhaps a variable. It's usually question 9. Anyway, let's go. In this diagram, the center of the circle is A, okay? Angle ABD is 20 degrees, it's indicated, and angle DCA is essentially equal to 52 degrees. So DCA, those of you who are flirting with the limits of medicine, this is what we call the distal carotid artery. Artery, is it the artery or is it the artery? Yo, it's the artery. Anyway, it's the artery or whatever you will. Guys, pronunciation has no master. Although some people like me, okay, maybe let me not count myself as those people. Some people believe they are the masters of pronunciation. But my worry is that most of them do not even understand phonetics. It's not even part of the standard schooling syllabus at the moment, and yet it used to be. And essentially, if you listen to someone who studied long before we did, they have this tendency to have the right pronunciation. Take away the accent, it's usually the problem. A lot of people listen to the accent and then think that person is not actually giving the correct pronunciation, but the pronunciation was usually very correct from those guys. Now, the generation that doesn't really study phonetics as part of their teaching in schools, yeah, whatever. Let's leave it at that. Now, what is the story here? We need to find angle BOC, the bulk. Where is BOC? This is the angle in question. So we want to use... okay. But now how can we find this bulk? If you look at these things I just spoke about. So if you look at these two triangles, do you realize that this is an exterior, it's a common exterior angle of these two triangles. So that means we can use the yellow triangle or the green triangle to find this. But it would mean we then have to find what these angles are. Our task is to find this angle if we are going to use the yellow triangle, or we have to find that angle if we have to use the green triangle. So which one is easy to find? Now take a look at this. Now guys, take a look at that. You see this red triangle, the outline? We know these already. So they are all equal. So this is an isosceles triangle. So it means if this angle is 20 degrees, then that angle is also 20 degrees. Great. The other stories that we can tell here is that if this angle is 52 degrees, remember this is an isosceles triangle, that angle as a whole is also 52 degrees. So which triangle is most likely going to give us what we want? You guessed right, it's the blue triangle, because it will give us this small angle there. Once we get that small angle, we can use these two to get that BOC. So we can see clearly that we need to pull that 20 back into that blue triangle first. So let's see. We'll start in triangle ABD. The abdomen. We understand that this angle here, ABD, maybe let's not use ABD. We're going to say ADB is equal to angle ABD equal to 20 degrees. Why? These are angles opposite equal sides in a triangle. Seeing that already AD is equal to AB. All right. So again, this grade 8 theorem of isosceles triangles is also another very useful tool. So you cannot escape this, guys. You just can't. What can we say? We know without a shadow of a doubt that in triangle ACD, what is the story there? We understand that this angle ADC is equal to angle C. Maybe let's not say C, but ACD. Or they said DCA. Maybe let's use what was given to us. DCA equal to 52 degrees. Again, same reason. Angles opposite equal sides in a triangle. We're talking about that. This is because the radii AC is equal to AD. Nice. See? It becomes a common means to an end, guys. So now our little bit of the puzzle is somewhat sorted. So if we want, we can move on and work out this little piece, because we want that little piece here. We can say but here. We understand that this angle, can call it BDC. or maybe let's call it ODC plus this other angle ADB is equal to 52 degrees. Because, I mean, we just proved it. We wanted to use it. Perhaps let's not rush to say 52, but we can write that angle, which is ADC. This one is evident. We don't have to worry. So ODC is what we want. Plus ADB. ADB, we realized it's 20 degrees, is equal to 52 degrees. Therefore, ODC is equal to 52 minus 20. This is what? 32 degrees. Remember, I don't have a calculator, guys. 2 minus 0 is 2. 5 minus 2 is 3. So basic arithmetic calculations need to be on point. We can say then, in triangle, I mean, you may name triangles as you go along if you will. It's not a big deal. But for me, I just like to jump in for the final one because I'm tired of naming triangles. I'm going to say here, this angle that I want, COD, the chord, Tetinyongo boy, this is BOC, the bulk is equal to the sum of angle DCA plus this angle which has found ODC. Y, exterior angle of triangle. This time we didn't want to name it separately. We're going to say COD. So, as long as someone understands, okay, you're talking about yet another triangle. And it does look like that indeed. So this implies that our bulk is equal to DCA is 52 degrees plus ODC, which is 32 degrees. Therefore, our bulk is equal to, again, a simple addition here. 2 plus 2 is 4. 5 plus 3 is 84 degrees. Some basic arithmetic calculations must be on point because you don't have a calculator. So what does that mean? It means this is D. Okay, this one was not so labor intensive, but it was a question that forced you to walk a mile, just a mile, to get somewhere. So this is a trigonometric one. Okay, guys, so this is a course on NBT and essentially maths in general. So I hope you are enjoying it so far. Obviously, when you get tired, pause the video, go get some snack, eat something, chat to a friend, go kick a ball. You can even go away and come back later and carry on. All right. So I'm just trying to give you almost everything at a go so that you don't spend too much time trying to find these videos if I break them into pieces. So when I have something big and important to give it to you guys, look, when I have something big and important to give to you, I will always do it at the longest time it needs me to take it. All right? But when it is something that perhaps is just to emphasize a small point, I can do things in bits and pieces. And yeah, that is just my strategy. Anyway, let's have a look at this. This is given to us that f of x is equal to sine x. Now you already know what we know about that story. So this is the standard sine graph, period is 360, and the amplitude is 1, saying the maximum is at 1, the minimum is at -1, intervals are of 90 degrees. Great. So we know that. And obviously, just to give you a picture, okay guys, so this is basically the standard sine graph. So I did this quickly just to leave you with something. So can you see the amplitude is at 1, period is 360, and that's it. Now we are told here, what is the equation of the graph below? Obviously keeping this one in mind. Okay, so this is our reference point. So this is trying to suggest, don't sweat looking for the graph here, because usually when given a graph in trigonometry, we need to compare it to its past, which is the original or the standard sine graph, if it is a sine graph or whatever. So because the algebraic tool here of doing that is a bit painful, okay? You don't want to go about it. It's not nice. It's not easy. So we always do this by comparison. So this is a guide, basically. That look, take the guide and then compare. Now what do we see? This is suggesting that we're dealing with a sine graph that is transformed. So this is a transformed. So this is basically suggesting that. Now we can see that sine was supposed to start at 0. Right? Because sine of 0 is 0. But now the first 0 we see from the origin is at 30 degrees ahead of the origin. So this means this graph was shifted 30 degrees to the right. 2. We were supposed to hit a maximum at 90 degrees. But now we can see that the maximum is at 120 now. Can you see? The maximum is at 120. So the maximum was supposed to be at 90. But now it has shifted to 120. Can you see? Now, between 120 and 90, it's 30 degrees again. So we can see that the maximum shifted 30 degrees to the right. So we are convinced this is a shift to the right by 30 degrees of a standard sine graph. But now here's another issue. This maximum is at 2 units. Normally, this was supposed to be at 1. So it was at 1, but now it went to 2. So what does that mean? It means the amplitude is at 2. So we augmented the graph. Basically, this means it's an augmentation of sine. Is sine written like that? I don't remember. Of the sine graph. Maybe let's say the sine. The sine graph by a factor of 2. So that means 2 multiplies the function. So this is very easy. So it's actually very easy because now we can understand that this is the standard sine graph that is augmented by a factor of 2 and then shifted to the right by 30 degrees. So let's write it out. So we can see here that what we can appreciate about the given graph is a standard sine graph that has been augmented by a factor of 2 and then translated to the right by 30 degrees. Ne? So therefore, we know here that this g of x is basically 2 times our f of x. F of x. Now to translate that 30 degrees to the right, we subtract on the inside. So that is what we can see happened here. Okay, wonderful. Now what is that answer? It's C. Can you see, guys, the knowledge of these functions from their standard form is key. So please don't play hide and seek here, guys. It's dangerous. It's dangerous. It's dangerous, that thing. So don't do it. Don't do it. Don't do it. Okay. All right. Okay. Right. So there's even more areas one can look at. Think of sine of 180. Sine of 180 is 0, right? But you see now this has shifted 30 degrees to the right. So there's more you can say here. So that definitely there is a horizontal shift to the right. And it is augmented because we increased the vertical extent. We didn't shift it up, but we just augmented it. What you call, when people take their portraits for augmentation, is dilated. What is the other word to show that something has increased in size? Yeah, maybe we can just say it has increased in size, but still hitting the same marks. Okay, let's move on, guys, before we spend more than is necessary on this question. Did I even pick an answer for these ones? I did not. Therefore, the answer here was D. It's important because you need to know the answers. You need to know the answers here. So therefore, the answer on this one became C. Okay, so remember, all of this information is talking about the diagram. So what I'm thinking I'm gonna have to do, I need to give you 3 PDFs then, because you probably want to also visualize my actions on the questions here. So I'll make sure that you can download this as it is, as I have written into it, like here. Then I will try to clean it up, then give you yet another PDF where this is clean so that you can use it as your question paper. So I'm giving you bulletproof study notes. Maths can be studied actually. Anyway, guys, this is a course, isn't it? It's a course. This is not anything else. It's not a lesson, it's a course. In a course, you sweat, okay? So that you don't sweat when the exams come. Okay, let's try and finish this, guys, in no time. Now, the diagram shows circle center O with a tangent line. See, center is O, the tangent line is PT drawn at P. So there is our PT there. PT there. That's 10 from Patakabi. Okay. Now, we have the center O. Now we can see lovely tangent perpendicular to radius is the story there that we need to consider. Now we are told here also the 10 chord theorem comes in. Maybe let's look at it and say 10 chord theorem tells me that that angle will be equal to that angle. Right. And more. This angle will be equal to that angle. 10 chord theorem. Now we are given here that TPR, this one, is equal to 40 degrees. Now, find the size of OPR. So where is OPR? OPR. So we are looking for that angle there. So we want this angle. Okay. Well, our tangent perpendicular to radius is not going to help, is it? It will. Pantenda sokola for nothing. Remember, we said tangent is perpendicular to radius. So if we can use that property, we know that it's going to be just 90 minus 40, which gives us 50 degrees. Wow. So that is great. So this one is quick. So we can simply say here, OP is perpendicular. In fact, let's not even use that statement. We can just say angle OPR is equal to 90 degrees. Not OPR, but OPT. This is because the tangent is perpendicular to radius. Easy. We've got a story to tell that, but what do we know? We know that this angle OPR plus this angle RPT is equal to angle OPT. That's just evident on the diagram. We don't need to justify this. We are interested in OPR plus RPT. This is 40 degrees, or TPR, whatever they called it, is going to be equal to 90 degrees. Therefore, this OPR dude is 50 degrees. Done. Yeah, they were a bit lenient here. So that means our answer is D here. Nice and easy. So, so knowing the theorems well is key, guys. And make sure you are answering the right question also. Because you know what? I was thinking of this now. POR. That's why I was saying this is not going to help. But in any case, we're still going to help because we could use the isosceles triangle here because there is already. So we could use that and then work it out. Or we could use the 10 chord theorem and then the angle at center is twice the angle at circumference. And we would have that Then we could even use that to work out that OPR, but the quicker way is the best way. Other ways are labor intensive, but they still answer the question. Okay guys, let's get to some more Euclidean geometry. 108. We are told here in the diagram not drawn to scale, BC is parallel to EA, so that is indicated. Then MA is equal to 3 over 8 MN. Now this needs you guys to simplify it, okay? If you don't simplify it, you will die a slow death. So the best thing to do here, divide by MN. So it means MA over MN is going to be 3 over 8. Can you see? Nice now. MA over MN. So we say 3 over 8. So we can easily say 3A. This one becomes 8A. Always choose a multiple because in a ratio, these are not units. There's no units there. So we don't know what it came from. We may have simplified a bigger equivalent to this in terms of the values, although it amounts to the same answer. So don't make that mistake. So always choose a variable to multiply so that you keep these in proportion, so that we cannot get the wrong answers if we need to find the distances. Okay, and then we are also given another one here, that 2MB is equal to BE. All right, so what can we do here? The best is to divide by MB. So this means BE over MB is going to be equal to 2 over 1, right? Right. Again, be smart. Don't take BE and divide and then force yourself to make it a half. It's not a big deal. Don't do it. But you can still do it. It will still give you a similar setup. So what is that? BE. BE over MB. Can you see? Is 2 over 3. So we can say literally, we can make this one 2B, then this one becomes B, because we don't really write 1B, do we? We don't. So this is good. All right, so there we are, guys. So be able to perform these tasks. Ne? Great. Now what is the story? We are then supposed to find BD over DN. So this we can do if we focus on which triangle. Remember, this is proportionality theorem. So this means we will need to finally get to this triangle. All right, great. But now where do we begin? Now for us to work, obviously, if one looks at this situation right here, can you see this is entirely 8 portions of A, while that one only occupies 3 portions of A. This means this remaining portion of A is going to be 5A, isn't it? It's going to be 8 minus 3. It gives us 5A. So our main challenge is to find out this CA. Our problem here is CA at the moment. So we need to find CA. So what is CA here? Whew, in terms of A. That's where the problem is. Now guys, look at this red triangle that I outlined there. Does it really help us? Yes, it does, because we can get the ratio in which MC is divided by, in which MA is divided by this line BC, seeing that that is parallel to the third side, so it should cut those two sides in proportion. And then it will tell us what is that value over there. And obviously it will also tell us what is this value to MC. Okay. So we've got some work to do here. So let's start. In the red triangle, in AMC, not AMC, but AME, AME, in AME. What do we know, guys? We want MC. We know that MC over CA, California or Cape Town. Cape Townians like to think they are in California in the US. Is it not so? Anyway, it's nice to fantasize, is it not? Wishful thinking. It's going to be equal to MB over BE. Why? This is the prop theorem. Always state the sides that are parallel to each other. Okay, because that reason is not complete if we don't see that, because it only applies when a particular line is drawn parallel to one side of a triangle, cutting the other two adjacent or opposite sides in proportion, or in the same proportion. Great, so this means our MC motorcycle over California or Cape Town is essentially MB is going to be B over 2B. Now remember, these B's must show up in your diagram. They must show up. Otherwise, don't write them here if you didn't show them in the diagram. Normally, this is when you're writing an exam where this is to be displayed. But in this exam, even if you don't write the reasons, but be sure you write them, because when you want to double check you selected the correct answer, you need to be able to follow what you did. Maybe let's start by saying this implies, and then we can say therefore MC over California. Remember, the B's will do the thing that can be done. Speaking of breaking English to pieces, why not? We can, brothers. We can, brothers. So now we get the idea that, okay, this is now, CA is two portions of that story. So this is going to be 2A this is now 2A, whereas this is A. Now we can see that A plus A gives us 3A. So this is now tying nicely. I hope you guys can see. Now that is all we needed. We can then go on and say then in triangle BCN. What is there? We understand that what we are looking for, BD over DN. Now remember, this is written in ratio form. Whatever that is, it means divide or division. So the best way to start is this way. This is going to be equal to CA, California, over AN. Okay, I don't know what that is. Now again, we say prop theorem. Please state the parallel sides. We understand that BC is parallel to AD. Now that reason is complete. This implies that BD over DN is going to be, CA is basically 2A over, remember we didn't specify this was 5A. We need to show a calculation. It's 8A minus 3A because what was given was those two. So we did not establish as yet what that was. This implies that BD over DN is equal to 2A over 5A finally. Now those things do the thing. So we can conclude that therefore now in the manner that is required, BD is to DN is equal to 2:5. Where is that answer? Option D. Okay guys, so obviously I'm taking you through the steps that are necessary to be taken to get these answers answered correctly. At the same time, I want you to be in a position to see where you went wrong or where you made mistakes in case you did. Because if you are quick and smart, you can do this and still answer this within reasonable time, sparing some time to revise if you've done all the right things, you've answered the correct questions. Because remember, this NBT thing decides whether you get placed in a particular course of your choice at a particular university of your choice. So you don't want to take this for granted. Yes, it's not necessarily going to say you are going to be rejected, but this can help in placing you in the right spot for the right career path. All right. Let us not spend too much time here. We can say, therefore, the answer is option D. Like I said, you will find these diagrams annotated like this and these answers detailed like that for reference purposes. And there will be yet another PDF where these pages are clean so that you can use them as your questions. Let us charge ahead. We only have, this is the last question, so that's good. So we've got the second last. Finally, we will be done. In the given figure, AE is equal to DC. AE is equal to DC and equal to 3 units. So this is 3 units. Okay. Now AB is equal to 10 units. So AB is 10 units. AD is 4,5 units. So this is 4,5 units. And then we are told here, if GDE is parallel, GDE, so this line is parallel to CF. Okay, find FC over EG. Okay, FC over EG. Okay, this still uses proportionality theorem, but in a smart way, because here we've got to consider almost like similar triangles, if you ask me. Sometimes it's better to look at it that way, but still proportionality theorem holds. But we should be able to say this whole side over this should be that side over that. So we can manipulate that. So that means if this is 3 units and that, therefore it means this guy. It means that guy. Do the things how. It means EB is going to be 7 units, isn't it? Because 10 minus 3 is 7. But now we still don't know what FB is. Our problem is FB and EF. So we need to find EF at least, because we can find FB easily. All right, so what needs to be done here? Well, it is this. So what needs to be done here, guys, is to use this triangle with this side drawn parallel to the other one. So we can use the proportionality theorem here to be able to work out EF. Then once we have EF, we have FB, and we are sorted. Because at the end of the day, we want to land up in that blue triangle. Okay, let us start. 103. We understand here that in triangle ACF, how sewenze njani manje? Sendiniwe. Anyway, what do we know? We want EF here, so we can start with EF over EA is going to be equal to CD over DA. Again, prop theorem with DE or ED parallel to CF. Okay, so that is great. So this implies that EF over EA is 3 equals CD, it's 3 over DA, which is 4,5. Then here we just cross multiply that 3. This implies that our EF is going to be 3 over 4,5 times 3. Now what is that? So basically this is 3 times 3, which is 9. 9 divided by 4,5 is just 2 units. Okay? Now basic arithmetic, guys, must be a strong point if you really want to do well in this exam. Now, if this is the case, what do we know? We can even conclude now that okay, let's not conclude anything. Let's leave it at that. We don't have to worry about anything. But it means if this is 2 units, if this is now 2 units from the calculation, this then means this one is going to be 5 units, right? But remember, I'm going to write this one because this one we did not determine as yet. It's effectively 5 units, but I'm going to put it in brackets. 2 is valid to be there, but this 7 also, let's put it in brackets because we literally have worked it out, but it was not the question as yet. Let's be clear about that. We can say now in triangle EBG or GEB, we can set up the proportionality theorem there. So what do we know, guys? We know that essentially if we want CF over FG, what we need is to literally use these sides. I mean, how you start is really not a big deal. For me, I'm going to say FC over, now FC over this side, FB. That's the best way. That's the best way to do it. FB must be equal to EG over EB. Okay, that is good. This is the prop theorem with CF parallel to EG. Okay, so this is good, guys. Again, you can use similar triangles with their proportional sides. It's not a big deal. But you don't want to go about it the long route. When this is already set up, don't struggle. Proportionality theorem still accounts for this. Now, what do we have, guys? we've got FC, which is what we want, over FB. Now can you see FB is what we need to determine. So FB here is essentially 10, né? It's 10. The whole side was given to us as 10. So we need to perform some gymnastics here now. This is 10 minus 3. Right? 10 minus 3 gives us EB. Then we subtract 2 is equal to, now this is going to be EG, which is what we want, over EB. Now EB is part of this business here. We were not able to do it as yet, so this is 10 minus 3. Okay, so it is nice to show these calculations at some point, especially when you are lazy to do multiple calculations that are boring. The only thing that you need to make sure doesn't happen is mistakes, okay? Simplify, simplify. So basically this is 10 minus 3, 7 minus 2, this is 5. Can you see? Great. Now that 5 comes out, and then we've got EG over 10 minus 3, this is 7. That 7 comes out. Now, all we want to do, I know guys, I am very capable of performing some crazy things here. I know that I can actually pull that G down and I can pull that 5 up. This is still a valid gymnastic. Obviously, not going to show people this. You can just come up with a conclusion and avoid unnecessary stress. So we can say therefore FC over, so we pulled EG down, so it's going to be EG is going to be, we pulled 5 up, it's going to be 5 over 7. I dare you guys, you may think I'm crazy, but some shorthand techniques. When you have an equal sign in fractions, you can pull anything to the other side in a cross fashion, so to speak. It is valid. But if you want, you can go about it the long way, say cross multiplication. This is literally cross multiplication and dividing. You multiply the 7 there, it's going to be 7 FC. Multiply the 5 there, it's going to be 5 EG. Then you divide by EG on both sides. EG cancels on the one side, and it goes there. Then you divide by 5 on the other, by 7 on the other side, or whatever. So you've got tricks and tools to handle this situation, okay? Yeah, whatever. Let me show you, in case guys you think I'm showing you crime. I know you think I'm a criminal. If we cross multiply the standard fashion, we get 7FC equals 5EG. Ne? So what do we want to eliminate is EG and 7. So we can divide by 7EG. Divide by 7EG. Remember, you can divide by anything you want. That cancels. That cancels. Therefore, you end up with FC over EG is 5 over 7. So maths needs to be flexible in your brain, guys. So, and you can see that if you can do it this way, then this is allowed actually, technically. But let's leave you there. So we need to give the answer in the required fashion. FC is to EG is going to be 5 is to 7. And where is that? That's option A. Okay, guys. So we are doing great. We are doing great. We can say therefore our answer that we need to pick is option A. Okay, guys, I challenge you, don't, when you study, avoid just finding answers and that's it. Especially for questions like this where there's other answers given. Find out what are those answers in this diagram. Do they even exist? Because these are some of the mistakes you will do here and solve other things here that come out like that. This is when you really are trying to study better, because you want to know, are these answers gibberish or are they part of this diagram? That way you get to learn better. You become complete. So don't be lazy. Don't be lazy, folks. Now let's tackle this last one. I'm not going to do a lot here. I'm just going to write it here, 95. Now it says here, 4 equal circles, that means they have the same diameter or circumferences, are drawn to fit exactly inside a square. Okay. Now a smaller square is drawn with its vertices at the centers of the 4 circles, right? Find the ratio of the area of the smaller square to the area of the larger square. Great. This is so easy. Now look at this. This is the radius of one circle meeting the radius of the other circle, right? But since these circles are equal, then it means those two sides are also equal. Maybe let's use a different color to show the equality. Great. Now that is fine. So if we let this one be x, it means that one is also x. But can you see this radius is still going in that manner? And it's still going in this manner. Still going in that manner. Still going in this manner. I'm just showing these arrows pointing at each other in a way to avoid some issues. So if this one is x, we know that these radii are all equal, guys, because they are from equal circles. So equal circles will have equal radii. Interesting. So that is great. But then if we are to extend, remember this is a square as well. It means that side is equal to that side, equal to that side. So now if we extend our radii into our diameters, okay, we extend this into some diameter there and extend that into some diameter as well. Guess what? It would still be the radius. It would still be the radius. Maybe let's even extend it literally. Let's extend it literally. So this is also the radii. So can you see? So now we can just deal with the problem. We can say here area of the small rectangle, not a rectangle but square. You can say small square over, because we're supposed to find the ratio of the area of the smaller square to the larger one. Say area larger square is going to be, remember this is s squared over s squared. But now what is s here? You see the side of this square includes 2 equal radii, so that's going to be 2x squared over. Now again, this is also a side squared, but now do you realize how many radii make up that side? 1, 2, 3, 4. So this is 4x. So this is going to give us basically 4x squared over 16x squared. I really don't like to stagger when I write, but yeah, I ended up in that situation. 4 goes once, goes 4 times. So when we simplify here, what do we get? we get 1 over 4. So therefore our answer here is going to be 1:4. Right. So that is B. That is B. And therefore the answer to be selected is option B. Okay guys, so I hope you enjoyed the video, folks. It took long, obviously, but if you are someone who watches my channel, you realize that I often do a full paper from start to finish. It usually takes around 3 hours 40 minutes, especially when I am trying to be as comprehensive as possible. So I hope you will enjoy this course, if you call it a course, or this study session, so to speak. Some people can concentrate for 3 hours and then they start to dwindle. That's why most of your exams are for 3 hours. Anyway guys, I hope you liked the video. I will see you some other time. Goodbye.